All right, hello calculus. Welcome to your chapter 4 exam review video. All right, now if everything goes to plan, we'll see. Your exam is currently scheduled for Friday, February 1st. All right, now if Elsie is born before that and you have taken your quiz, your second quiz, then it will be the day I come back. If not, we'll do the quiz the day I come back. We'll have a few days of review and then we'll do the test. Okay, so anyway, watch Act 9 videos for more updates. Folks, this video is just going to serve as giving you these answers. By this time, when we take a test, you need to know how to do these questions, all right? So if we're looking at this to figure out how to do these questions, this video, we're going to be in trouble, all right? So we should know how to do these. You should have practiced this several times and give you many copies of this review. We need to do this review at least 3 times. I kid you not. I hope you take that seriously. As always, brought to you by Chinatown, Bobo's Oat Bar, Veggie Straws. All right? Folks, 1 through 3, just find min-max values. Obviously, you're going to test where this interval starts and ends. There. Take the first derivative, set it equal to 0. What do these have in common? We had a lot of issues on the quiz with something like this. They only have like 4x in common. Factor it out. Left with x squared minus 1. You're going to have 3 solutions. X equals 0, x squared equals 1, so x is plus or minus 1. Testing those 5 values. Plug them all into the original, folks. Folks, do not plug it in to your derivative because 3 of those are going to be 0. They are critical values. Always plug it into the original. There's the winners. If it's a tie, then call them both the max, both the mins. All right. Next one, take the derivative, set it equal to 0. Notice how your critical numbers are positive and -2. -2 is outside the interval. You're only using 2 here. Okay. Be careful, just read. There are the winners. You always plug it into the original. It says f of, not f prime of. Okay, folks, as I told you, from literally the middle of August, you need to know the unit circle values, and you still do, or else we're getting this question wrong. Take the derivative, set it equal to 0. Sine x is 1/2. All right, sine is positive because it's y, first and second quadrant. All right, and the interval is 0 to pi, which is the first and second quadrant. If you do sine inverse 1/2, it's going to tell you 30 degrees, which is pi 6. Pi 6 and 5 pi 6. Again, we need to know those, folks. You need to know the unit circle. All right? So plug in 0, pi, and then those 2 critical values, and there it is. You can round it to the nearest 2 digits or write it like that. Those are your winners. All right? Again, I'm going to start just giving you answers. This is more explanation than I thought. All right, find the critical values, just set it equal to 0. Boom, there it is. The derivative, set the derivative equal to 0. Okay? Again, this will never be 0. This will never be 0. Okay, e to the x is never going to be 0, so just set that equal to 0. All right, there it is. I know I numbered yours a little different. This is last year's review. There it is. Okay, again, factor out e to the x. This will never be 0, so simply set that equal to 0. And that's what you get. Derivative of natural log u is 1 over u times du dx. That can't be 0. Remember, you always set a critical number is when the derivative is equal to 0 or undefined. You get 0 as the answer to a fraction if the numerator is 0. This will never be 0. All right? If you set that equal to 0, you get I, plus or minus I there. All right? Set it equal to 0. There's the derivative. Use the quadratic formula. There it is. All right. Find all the values of c that satisfy the mean value theorem. Folks, mean value theorem is simply the derivative is equal to the slope of the the straight line between those 2 points. Derivative is equal to slope. Let's just get that in our heads. Derivative is equal to slope. So you do f of b, and that's b, that's a, over f of a. Okay, so the change in x is simply 6. Change of y over change of x. All right, you simplify that. Take the derivative, set it equal to slope. The slope is 29. Now I moved over 29. I moved over 29, so I subtracted it. I divided everything by 2, use the quadratic formula. Now it's got to fit in that interval. So the one, if you check it, the thing that fits in the interval is that one, not the negative version, okay? Okay, we're going to practice that a bunch. Take the derivative, set it equal to the slope. You're going to have the straight line between x is 0 and x is 4. All right? That's f of 4, that's f of 0, 4 minus 0. Slope there is 10. Move that over. Take the square root. You're not going to use the negative version because it goes from 0 to 4. You're going to use that. Find where it's increasing and decreasing. Take the derivative, set it equal to 0. Now notice here, x equals 0 is a critical number. It makes the derivative 0. Folks, we really got to clean this up. Look, you're subtracting all of this. Too many of us put like -1 as our final. It's you're subtracting -1. That makes it positive. This will never be 0. Your only critical value there is 0. So remember, you can get when one of your critical values is a vertical asymptote, which that is, or makes the derivative undefined, you can get this case where it goes, from increasing, or it skips. We had a lot where they're alternating. This case it is not. Okay, this next one, again, you use the quotient rule on both of them. All right, quotient rule, this will never be 0. So your only critical value is x equals 0. All right, two intervals, goes from increasing to decreasing. There it is. Here, just take the derivative, set equals 0. I think this literally came, this is almost identical to something you saw earlier this chapter. So take x squared out, 0 and 3/4, so your critical numbers. Interesting. It goes from decreasing back to decreasing. So you can say -infinity to 0, union 0 to 3/4, or you can go like that. Okay? All I asked for increasing and decreasing. That is it. I didn't ask for it all, which the next three have it all. Again, just check this work. Those are your two critical values for the first derivative. There it is. Increasing on those, decreasing on those. Again, check this. Pause it if you need to. All right, so when it goes from increasing to decreasing at -3, you have a max. Plug -3 into your original. When it goes from decreasing to increasing at 6, you have a minimum. Plug 6 into your original. Take that first derivative, right there, and then take the derivative of that. Set it equal to 0 for concavity. 3/2. At that point, it goes from down to up, so your inflection point is at 3/2, and then plug 3/2 in for x. I didn't do that, so good luck. All right, next one. There it is. Take the derivative, set it equal to 0. 2 and 4, your critical numbers. All right. Increasing there, decreasing there. There's your max and min. Take the second derivative, set it equal to 0. You get 3. Concave down, then up. Inflection point at 3/16, which I did right there. Next one, take the derivative, set it equal to 0. 5 and 1, those are lovely numbers to deal with. Max at 1, 0. Min at 5, -7. Take the second derivative, set it equal to 0. Inflection point is 3, -16. Interesting. All right, folks, know how to do those. Then we get to the related rates question, the famous ladder question. I give you dx dt, sliding away from the wall. That's positive. The x distance is getting bigger. And I'm using the Pythagorean theorem. Take the derivative of that. The ladder is not changing, so dz dt is 0. And it makes sense that it's sliding down because it's sliding down the wall. The y distance is getting smaller. Spherical balloon, folks. Volume of a sphere. Take the derivative of it. dv dt is 24 because it's being pumped into. It's positive. All right. When the when the volume is that, folks, you got to do a little bit of work to figure out what the radius is. This did come from SIU Carbondale's calc final exam a few years ago. This exact question, I believe. And they did give you the formula, so I probably will as well. There it is. Okay, moving on. A few more related rates question, or one more at least. The oil from the drum. This dr dt, only the h is changing, so we don't have to worry about dr dt. It's 0. Again, you can use either the product rule, or r is going to stay constant, so we can just take the derivative, and only worry about h there. All right. Now, it's leaving, oil is leaking, so dV/dt is negative. It's negative. And that's the info. And there it is. So the height's, the height's decreasing. That's why it's negative there. This is an optimization question, which we talked about after related rates. It was not on your homework, I don't believe, and it was not on your last quiz. It could be on your test, so you will have one optimization question for sure. All right, so what do we want to max? We want to maximize the area. We are looking to maximize length times width, or x times y. X, y. I'm putting no fencing there because that's the river. Now, what I do know is I know that 2x plus y is 3,200. I have that much fence. So I'm going to figure out what y is in terms of x, and then I'm just going to, because again, I'm looking to maximize this formula right here. I'm going to get rid of y. I'm going to maximize this. If I want to maximize this, I take the derivative of this, set it equal to 0. X is 800. All right, 800, 800, and again, just use this formula here to figure out what y is. All right, and the last page, I believe, the square box. Again, one of these three questions you're going to have on your exam, something just like it. Square box means it's x by y with an open top. I want to find the dimensions of the box that minimize the amount used. So I want to minimize the surface area. Minimize surface area, which is x squared plus 4 sides that are x by y. Want to minimize that. I know that the volume is length times width times height, so x squared y. I know that the volume is 32,000. Now, what do we do here? We figure out what y was in terms of x. All right. So I want to minimize this. So I got rid, again, y is the easiest thing to get rid of. Plug that in for y. Did some simplifying because I want to take the derivative. It's x to the negative first. Take the derivative, set it equal to 0. Cross multiply. X is 40. Plug that into that formula that I knew. And y is 20. Profit equals revenue minus cost. Now, obviously, this question isn't great for now because you're going to sell a smartphone for more than whatever dollars here. All right, the profit is the revenue. The revenue is x times what I sell it for. All right, that's the revenue. How many you sell times what you sell it for, minus the costs. Okay, it's just that it's going to cost $50 for each smartphone. So 50 times x plus, 6,000 a day. Okay, so that is the profit function. I want to maximize this. So take the derivative, set equal to 0. That's pretty cool. If you go into business calc, do business, you'll be doing this a bunch. You should make 600 a day to maximize profit. All right, this is our exam review, folks. Study early and often. All right, Siak Math Videos signing out.